All right, welcome to Realty Calculus Day 1. Today we're going to start diving in to figuring out what the basics of calculus are. So yesterday in your little beginning of calculus book, you were asked to define what it means to be a limit, define what it means to have a limit. So the definition of a limit, there you go, is to get really close to a value but not actually touch it. So for example, think about your driving. You're supposed to get really close to going 55 out on 34 over here. You're not supposed to go 55. It's a limit. That's what you're supposed to get really close to. So keep that in mind when you're trying to understand a math limit. Okay, so our first problem is x cubed minus 1 over x minus 1. We know that since we talked about using our domains, we just had that test over it, that we do not want x to be 1. X cannot be 1 because that means that my denominator would be 0, which is big no-go. So we're going to take a look at what happens when we get really close to 1. So go ahead and grab your calculators out. If you don't have one already, go ahead and pause the video so you can get it. In my calculator, I'm going to type in these values, and I'm going to show you how to do it nice and easy, so that way you don't have to plug it in the same way every time. So what we can do is we can store that x value as x. So I'm going to take my first example of 0.99. On my calculator, I'm going to look to the left over by it between the 4 and the 1, and I see the STOR button. So I'm going to type 0.099. I'm going to hit that STOR button. Not what I wanted. Kind of has a little bit of an arrow going to it. And then I want to store that as x. So I'm going to look for my x button, which is right next to my alpha. I'm going to hit enter. And now when I hit x, I'm going to have that 0.99. So now that we've got that stored, let's figure out what my x is. Let's figure out my y is when x is 0.99. So in my calculator, I'm going to take x cubed, which you should know we can get to with our little caret key, minus 1 divided by x minus 1. You should get about 2.970. Okay, let's try that again for the 0.999. So 3 nines this time. So same idea. We're going to hit 0.99 store x. 3 nines, I apologize. Now we're going to go ahead and, since we had already typed in there my x cubed minus 1 divided by x minus 1, I can hit, since I've restored my x, I can hit second enter to bring up my store, and then second enter again to bring up my equation, and hit enter. So that way I don't have to even retype the equation every time. So then when you do this one, you should get 2.997. Okay, same idea. Now we're going to do 1.001. So we're going to store that into our calculators. We got about 3.003. And then for that last one, when we do 1.01, I get 303. So it looks like when I mathematically calculate this out, I'm getting really close to what value? I get pretty close to 3. Okay, now what we're going to do is we're going to take a look at the graph of this in my calculator. So go ahead, grab your calculators out, go to your y equals button up at the top. Type in, your equation. Now, I understand that we had already stored different values for x. But once I plug in x here, it does not recognize that x value that you have stored it as. It takes it as a normal x, so we can go ahead and change it around. So x cubed minus 1 divided by x minus 1. Hit your zoom button, go to 6 for standard. Now you see a normal parabola, correct? Well, we know that we don't really have a value at 3, right? So when x is 3, it doesn't really exist. Excuse me, I'm sorry. When x is 1, it doesn't exist because we're getting really, really close to 3. So when we draw this graph, we know we're going to have a hole there and a parabola like such. So I took a rough sketch. Now, again, mine doesn't look exactly like my calculator does, but that's a rough sketch of what this graph looks like. Now, if you notice, you don't have a hole on yours because your calculator is just trying to insert as many, it's not a smooth line. There's thousands of different data points. That's why you can kind of see all those. That's why it's jagged. It does steps, so to say. So that's why yours doesn't actually display the hole. But we know we can't have x be 1. So what we've talked about here in 2 different ways is the limits as x approaches 1 of my function of f of x is the value 3. Again, we get really, really, really close to 1, we don't actually use 1. And when we get really, 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 really close to 1, we get really, really close to 3. All right, let's take a look at this next example. We're going to go ahead and use a table just like we had done in the example before. So what do we know x cannot be close to? Well, if you remember your domains, you can't have x be equal to 2. So we're going to get as close as we can to 2. So my x's, my f of x's. So let's plug in 1.99. That's pretty darn close to 2. So in my calculator, I'm going to hit 1.99. Store as x. I'm going to hit open parenthesis, x squared minus 3x plus 2, close parenthesis, divided by parenthesis x minus 2. And I come up with 0.99. Okay, let's get a little bit closer, 1.999, so 3 nines. Get a little bit closer yet. I also get 3 nines, I get 0.999. All right, let's try a little bit above 2 now. Let's do 2.001. I get 1.001. And then if I do 2.01, I get 1.01. So what number do we get close to but don't actually touch when x is close to 2? Hopefully you're all telling me that we get close to 1. So the limit as x approaches 2 of f of x is 1. Let's take a look at this next graph. So if you notice, we have 2 conditions on this graph. We know that x is 1, it's the graph of 1, when it is not equal to 2. But when it is 2, it's 0. So what that's saying is, when x is equal to 2, I have the point 2, 0. So I have this point right here. But any other time, it's equal to 1. And that's going to be the line y equals 1. Now, bear with me for a second. I can't really have x be in 2 spots here. So we're going to have another hole. Thank you. We're going to have another hole at 2 because we're told that when it is 2, my answer is 0. Otherwise, it's 1. So we're going to look at that green line to help us determine what my limit is. So when I get close to 2 of f of x, what value do I get close to? Do I get close to 0? Or do I get close to 1? My answer here is 1. The reason being is because it is 2 only at 0. Excuse me, I said that backwards. It's only 0 at 2. But when you get really, really close on either side of my graph, I'm still closer to 1. So even though it's telling me it is 0 when it's 2, because it's a limit, it's when I'm getting closer to something. It's not the exact value. It's going to be the opposite. Let's take a look at this next problem. So I have the line 4 minus x when x is not 1, and 0 when x is 1. Well, I'm going to rearrange that really quick. So I have negative, oops, don't know what's going on over there. I have negative x plus 4. Would you agree with me there? Up on that first little row. Okay, so that's the line. Starts at positive 4, so 1, 2, 3, 4. Just point there. It goes down 1 over 1. Well, we know that it can't be at 1 because when it's 1, it's 0. So I can't have a dot here. I'm going to have an open one. Down 1 over 1. Down 1 over 1. Down 1 over 1. There's my line. But I know that it is 0 when x is 1. So let's take a look at the limit as x approaches 1 of f of x. We're looking for my regular line. So where do I have my regular line? Well, that's the blue part, isn't it? So when we get really, really, really close to 1, but we don't touch it, what value do we see? Well, if I originally start here at 0, 4, this would be about 1, 3. So I get close to 3 in this case. Now there's another way to check this. What you can do is you can plug your x value in here. So if I took 4 minus 1, that gives me the value of 3, doesn't it? Now if it was a normal equation, if it was just that line, we know it would be 3. But in this case, when it is 1, it's telling me it's 0. So this obviously contradicts it. But that's how we can find that limit if we're given a regular equation. Now, in the example before, we didn't have any variables. It was only just 1. This one, we're given some manipulation. We have something we can change. So we can plug that one in. All right, let's take a look at this next one. Let's first start off by saying that we know that x cannot be 2, just to keep helping us refresh our brains. Well, I don't know what this graph looks like off the top of my head. So let's check our calculator. So go ahead and get your calculator back out. Go to that y equals button and type in 1 divided by parentheses x minus 2. The reason we do that is so we can keep that x minus 2 all in the denominator. If I just did 1 divided by x, then minus 2, if I did this, oops, 1 divided by x minus 2, it would take this division of 1 over x, and then that whole thing minus 2. But I want that negative 2 in the bottom with my x, so that's why I have to put the parentheses around it. What do you guys notice about that graph? what happens at 2? It doesn't touch it, does it? It's kind of like my graph gets really, really close, but runs away. So if you cannot recall, because it's been such a long summer, we have an asymptote at 2. We get really, really, really close, but we don't touch it. So when we have something that looks like a graph that looks like this, we're not getting close to either point. Because if you notice, my left side of the graph over here goes down towards negative infinity. My right side goes over to positive infinity. It's not going to the same value. So if we don't go to one consistent value, we say that the limit does not exist. Mean girl quote. So in this case, my limit does not exist. Okay, let's go ahead and take a look at number 19 on page 55. So if you don't have your book next to you, go ahead and pause and go get it. I will be slowly putting it on the board. So we have a hole here, and it kind of looks like this. And then we have dots, and then we have a hole, and then we have another hole. Here. So it, give or take, looks about like that. Okay, so in part A, it's asking me to find f of 1. So it's saying, what is the value of my function when f is 1? Okay, so if I'm going to look at my graph, here's my 1. I have 3 different potential answers. Well, if I go back a couple slides for a moment, bear with me. If we look at this example here, my x, when x was 1, my answer was 0, but I had a hole over here. So my answer for this first one is actually going to be my filled in circle. It's what it's going to be exactly at 1. So in this case, my answer is 2, because when f is 1, I have a solid dot at 2. Okay, let's take a look at part B. What's the limit as x approaches 1 of f of x? All right, so we're going to look kind of like the last couple graphs. So again, here's 1. If I'm looking from my left part of the graph, it looks like it's starting to approach 3. But if I notice I have another hole down here at 1, 1. So because my graph is not consistent, it doesn't come towards the same value, my part B does not exist. All right, part C. What is the f of 4? So that means I'm looking for an exact value when when x is 4. All right, so let's look at my graph. 1, 2, 3, 4. Well, it looks like it approaches 2, but I don't have a filled in circle like I do over when x was 1. So when I don't have a solid answer, that doesn't exist. There's no actual value. It gets close to something, but that is not the actual thing. Let's take a look at part D. What about when the limit of x approaches 4 of f of x? Okay, well, if we're looking at 4, we're looking from the left, it looks like we're approaching 2. If I look over here towards the right, it looks like we're approaching 2. Well, we're approaching the exact same number, so my answer here is 2. So notice the difference between finding the actual value versus finding the limit. When I'm looking for the value, it means I can plug something in and get a definite answer. If I'm looking for a limit, it means I'm getting close to something. All right, there's your homework. See you tomorrow.